topic, and my background is in robotics. So, as last year, as my master thesis, I built for us the prototype of under canopy robotic drone system that can avoid trees when it's flying under the canopy. So, little bit about the motivation. So, as we know, drones are becoming more and more popular also in the forestry field, but from above the canopy you cannot see everything. So flying inside the forest, it would open a whole new view for this forest monitoring and environmental monitoring and forest economy also. So, but the difficulty is flying inside the forest. Well, there is basically no commercial ready solutions for this. But in recent years, in robotics community, it has been quite widely researched topic, this kind of autonomous flying in GNSS denied environments where there is lots of obstacles and no information for the environment previously. So, yeah, this prototype, it was my master thesis, and I built it so that I did a survey to recent achievements in the robotics field, and I picked most promising open source algorithms as the base, and then built a prototype on top of those and tuned those to work so that now it can actually fly. And yeah, so the drone, it can sense the objects by only one stereo depth camera, and there is no GNSS at all. It is purely relying on visual odometry on its positioning. So it can go there and avoid obstacles. I can give local coordinate. It should deform its path so that it doesn't collide to any trees. It has no information about this environment previously. So maybe we can try and see if it really works. Today morning it was working, but of course this is our first prototype, so there can be kind of demo effects always. But yeah, there is one goal behind those trees, and the second goal is there behind of those trees, and then the drone should come back here, and maybe everybody could take a couple of meters behind for a safety distance. But I will have this emergency kill switch in case of any kind of non-purposed. But yeah, usually it will survive in this kind of easy forest quite well. There is not so that those very thin and needleless branches so much. So biggest problems in this prototyping still is like sensing of those kind of very thin and needleless branches that are, for every sensor, they are very hard to detect. And then when they are detected, they are well, hard to map there so that they do not inflate all the mapping area. But and also there is always, when you are using only visual navigation, there is always some drift there. So in the longer operations, it will still be a bigger problem when the position starts to drift at some point. But luckily we have some ongoing tests also for solving that. For example, doing loop closures inside the forest. We have done also some walking tests with the camera, and indeed it seems that it's possible to use loop closures to correct the drift also inside the forest. The trees are not too similar with each other. And also there could be GNSS, so that it could view GNSS and visual data, so that in the open areas of the forest it could use GNSS signals to correct the drift in the visual positioning, and when it reaches the densest part of the forest it could then rely purely on visual navigation. But yeah, this was pretty much it. So